Okay, which of the following is true? When I see this function, right away I see absolute value, and I'm like, okay, when you see, you think. Great thing to have out right now. What can absolute value cause problems with? Integrals, continuity because of limits. So either there are struggles with absolute value and integration, you have to split up at the zeros, or continuity because of limits. Because absolute value behaves two different ways on either side of its zero. Real quick, what's the zero of x minus 2? X equals 2. When we plug in x equals 2, if we were to take the limit right away just by plugging and chugging, why am I doing this? Check out discontinuities, vertical asymptotes, limits. I have an idea of what they're asking. X minus 2 all over 2, absolute value of x minus 2. If I plug in, I get 0 over 0. True? Yes. Okay. Here's the struggle. That means keep going. Now, could we do L'Hopital's? Technically, yes. If you wanted to do L'Hopital's, we would have to remember how to take a derivative of an absolute value function. So you would have to do derivative of the top is 1 all over 2 times derivative of absolute value of u. Remember, no quotient rule. F prime over g prime for L'Hopital's. It would be the absolute value of u, good, all over u times u prime. What's the struggle? I still have the problem. Does that make sense? Pause. If you're on the AP, should you take time to erase this? No, just tell yourself, forget it. Even on an FRQ, you don't have time for that. Okay, so instead we're going to have to think from below and above. There are two ways of doing below and above. Okay? One way is just to visualize yourself and say, okay, if I'm plugging in from below 2, that'd be like 1.9, right? If I was plugging in 1.9, wouldn't this be a negative? But wouldn't the absolute value switch it to be a positive? So technically, hold on, coming from below, I need to make it the opposite normal sign. That's also what you could do if you made this a piecewise function. You could say, well, sometimes the absolute value stays the same as long as that expression will be positive. And sometimes the absolute value needs to change or flip, but only when the expression will be negative. So you could have made the piecewise function. You could have thought of it over here. Some of you guys would have not even known to do that, but you could have thought about it visually in the sense of those two should cancel, but what is the sign? So if you thought about 1.9, this will be a negative, right? This, so 1.9, well, that'll be a positive, right? Those two would cancel, and I would have a 1/2 remaining. Because you want to be able to cancel out the x minus 2's. You want to cancel out the x minus 2. Ultimately, if you use the piecewise function. This is not a number over 0, positive or negative infinity. This is a 0 over 0. I see that they should cancel in some way, shape, or form, but what sign will my 1/2 end up having when I cancel this out? This side, it would be a negative. But the other side, if I were to plug in 2 from above to my expression, this is when my absolute value is staying the same. Once again, these are reducing. I will have a 1/2, but is it going to be a positive? Is it going to be a negative? If I plug in higher than 2, that's a positive. If I plug in higher than, well, that's always a positive. So from below, I get a negative 1/2. From above, a positive 1/2. And what happens if they don't agree? The limit does not exist if it says from two sides. And if the limit does not exist because they disagree, there will be some sort of jump, which is why the correct answer should have been C. Because from one direction, without even knowing exactly what this graph looks like, although actually I should know what it looks like, there's 1, here's 1/2, here's -1, here's -1/2. Kiddos, aren't these degrees tied? Ultimately, as you go to infinity, the limit will be 1/2, leading the leading coefficients. But even as I come in towards smaller numbers, these two, in essence, cancel just from below 2. It would be a negative expression, meaning I would be continually coming -1/2. From above 2, I'd be coming towards +1/2. Because ultimately, if I was to do some division, if I could get the absolute values out of there, check it. It's just a constant function with 1/2 and -1/2 remaining. Tyler, Sean, whoever's confused, go ahead.
No, I know you explained this, but we just have to put our corrections on the...
Yeah, on the exam itself in a colored pen.
Yeah.
On the exam itself in a colored pen. Okay, it's recorded if you guys want to come back and look at it anymore, but the long story short is for an absolute value function, you can always split it up as a piecewise, keeping it the same for some interval and making it the opposite with a negative for another interval. Okay, Charlotte, you had a question. Which one? 15 on this one? 1/5, right? Okay. Uh-huh.
Do we need to do corrections on the one that we're taking all this week? Like, let's do Friday.
Yes. Reason being, well, one that's due Monday, but due Friday. Because we're going over questions on both exams. So then, in essence, we should be answering someone's mock AP and someone else's practice AP at the same time. Does that make sense? Okay, so everybody, number 15 on 2017. How many of you guys got this wrong? Let's just do a quick vote. Okay, number 15. Of us got it wrong. Check it out. The graphs of the function f and g are shown above. Which is false? Which of the following is false? Pause real quick. This is talking about limits, right? Everybody? Everybody? Pause. Okay, let's just review. Beginning of the year, actually pre-cal. 2 guys in 2 cars on the way to meet at a diner, right? It's okay. 2 guys, 2 cars on the way to meet to a diner. What are they trying to show? Limit from below and limit from above. 2 different guys, 2 different cars, 2 different branches. The limit will exist. They will ultimately meet even if there's a hole. Can anyone explain why? Why does the limit exist even if there's a hole as long as they are both approaching the same point?
It doesn't matter what's happening at that point. It just matters what's happening around.
Exactly. And then the guy in the calculus in 20 minutes, remember, he's like, we always focus on a point. We got to look outside, look at the window, look through the window, and ignore what's going on at the point. We're not looking at what's going on in the diner. The diner could be burned down, but did they meet? Ultimately, yes. Their approaches were the same. They were headed the same place, whether or not the diner was there, whether or not the diner was locked when they tried to get in. They were there. Does that make sense? When will the limit not exist? One guy didn't check the updated location on Yelp. He went to the old location and he was wrong. It moved. This guy went to the new location, that guy went to the old location. Okay, so then checking it out. Why is the limit as x approaches 1 of f of x equal to 0 true? The diner moved because it burned down, but they both met at the old location. So they were approaching the same point. The limit exists. That's true. The limit as x approaches 2 of g of x does not exist. Why is that true as well? They're approaching 2 totally different locations. Yeah, no, 2 different diners. Does not exist. Good. The limit as x approaches 1 of f of x plus g of x plus 1. Now here's what gets a little funny, but check it. You have to come from below and above, plugging into f, from below and above, plugging into g. So you could think about it if you want. The limit as x approaches 1 of f of x times the limit as x approaches 1 of g of x. Okay, if I plug in, isn't that just f of 1? The limit as x approaches 1 of f. Am I going to choose 2 or am I going to choose 0? 0. It's a limit. I know we plug in. But what are we doing? A limit. A limit. So we're not going to plug in f of 1. We're going to say, no, we're getting closer and closer and closer and closer and closer. We're going to plug in 0. So 0 times, and the limit as x approaches 1 of g of x, well, hold on. The limit as x approaches 1 of, okay, hold on. We plug in 1. 1 plus 1 is 2, so we're looking around 2. Well, how do I take a limit around 2? Does that exist? No? Oh, that doesn't exist. That would be true. Does not exist because if I go to plug in 2, it's not the point, it's the limit.
Then why is the answer C?
As the false? Okay, hold on. Let's check out D then. That's okay. The limit as x approaches 1 of f of x plus 1, the limit as x approaches 1, of g of x. Limit as x approaches 1, plus 1 is 2, f of 2, that totally exists. Limit as x approaches 1, g of 1, that totally exists. Oh.
So what I was thinking was that
I would have canceled those out. I would have, just I'm showing you guys, I would have canceled that guy out. I would have these ones for sure. Well, must be. Now, pause. Let's go back and figure out why. I was just showing you my process. I would have gotten there originally, but I would have made this mistake on thinking for letter C. Okay? But hold on. Do you see how these are indisputable as to why A, B, and D are true or false? This one does not exist. Yeah, it's a jump. This one does exist. Yeah, they agree. This one has to exist. Everything's nice and pretty around those points. Everything's gorgeous. Look. Pretty, 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 pretty. It's fine. Okay, so then coming back here. Limit as x approaches 1 of f of x does not exist. .9 plus 1 would be below, 1.1 above 1 would be above.
for you,
Great question. Let me think about it. I mean, in my head, it's the messiest one, and in that it's the one that I looked outside the box for, looking at the limits instead of the plugging in. Plugging in, there is an f of 1. Plugging in, there is a g of 2.
I'm like,
So technically, you could have plugged in and gotten an answer. I'm still stuck on the it should have been a limit part. But out of those 4 answer choices, it's the worst. I'll put it that way. It's the least true. But I'll go ahead and look at it and try to get back to that tomorrow. Yeah.
because if you plug it in,
If you just plug in, you're fine. You would plug in this point and that point.
But then once you find that answer, you just find the limit x goes to 1 is a constant. Right?
That's one way of thinking about it. I thought you would have needed to consider the limit before plugging in.
So I was just thinking direct substitution.
But if you're thinking direct substitution, you plug in, and if it works, and it's not, okay, there you go. It's not 0 over 0, and it's not DNE. Because you would plug in, and you would find a point, and you would plug in, and you would find a point. I still don't like the piecewise function. Let me ask a friend about that one. Let me collaborate with someone on that one. That would be a nasty one. Next one. It is the worst choice. I totally agree with it being the worst choice. 14 on 2017. Wait, did you guys see me do process of elimination, though? It's a very valid technique. Coming back, number 14. The population of yeast is given by... where k is a constant. Hey, that's weird. What'd they give us? Exponential growth. Now, could we also have gotten the y where we wanted it to be?
That's what I did. Look, you didn't trust it. Did not trust that function.
Anyway, both ways work. They actually are giving you this exponential growth guy. That's kind of nice. At time t equals 0, the weight of the yeast, so y of 0 is equal to 120, measured in grams. Okay. And it's increasing at a rate of 24, so then dy dt, increasing at a rate of, that's dy dt, 24 grams per day. So these are our givens. Which of the following is an expression for y of t? Well, guys, couldn't we have plugged in some stuff?
Yeah.
We could have plugged in, for instance, the point 0, 120 right here. So that would have been 120. When that would have been 0, anything to the 0 is 1, so c equals 120. So we've had y equals 120 e to the k t. But struggle, we still need, but right away, can't we say, I don't think so. This is just me just showing you my process. Could something funny happen? I suppose. I doubt it, though. Okay, so now what? I need to plug in this guy. And this guy says when t is 0, when t is 0, oh, what is y? So when t is 0, y is 120. So I can say k times 120 is equal to 24. So then k is equal to 24 over 120, which would be 2 over 10, which would be 1 over 5. Dun, 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 dun. You don't plug in t is 0, you plug in y is 120. No. The rate of change of y, remember related rates, is dy dt. The rate is the derivative. Don't. Remember, we didn't memorize that. That was only for special exponential growth into k problems. It's not the rate as in the derivative. It's the constant of, no, that's constant of proportionality. That's a percentage increase. This one, they're not giving us percentage increase. They're giving us just grams. That's what you're getting confused on. Okay, I'm ready.
19.
On the same one?
Yes.
How many of you guys missed 19? Okay, you can look at your Scantron, right? I love this one. What forever card? Line tangent. Don't even think approximation. Okay, hold on. Stay focused. Stay focused. So, line tangent. What do we do with line tangent? Y minus f of pi over 2 equals f prime of pi over 2 all times x minus pi over 2. Isn't that y minus f of a equals f prime of a times x minus a? Right? So then don't we get to plug in and say, okay, so that's going to be 2 cosine of pi over 2 plus 1. Ooh, did you put in your parentheses? Equals f prime. It says at, so I'm doing it at. F prime, wouldn't that end up being negative 2 sine of x? And negative 2 sine of x? Oh, no, you're okay. Okay. Negative 2 sine of x, plugging in pi over 2, that'd be negative 2 sine of pi over 2 times x minus pi over 2. What do you got to remember? Starts with a u and ends with an init circle. There you go. I didn't know how to say that. Pi over 2. Isn't that 0, 1? Isn't cosine 0? Isn't sine 1? So you end up with y minus, that's 0. I still have a 1 left over, equals, that's going to be negative 2. X minus pi over 2. I have a tangent line. And what did they say to do? Use it. Plug in, x equals 1.5. Where? In the only spot an x can go. So you end up with y minus 1 equals negative 2 times 1.5 minus pi over 2. I know it's nasty. But if you guys think fractions, nope. Fractions, couldn't you do some distributing? Distributing, that was weird. Distributing, that was 3. Nope, the 2 cancels. The 2 cancels on both of them. And then couldn't I add the 1 and I would get negative 2 plus pi.
Do number 12 on 2017.
2017, number 12. 2013, 21? Number 12. Where is he? Oh. Number of gallons modeled by?
Oh, wait.
At what rate?
On 2017. Am I talking?
2013? Is that your mock exam? Okay.
Let's go.
2013. Number 12?
Yeah.
Dude, last night was a blur. Oh, amen. Amen. Which ain't student grade? Why is it not a FRQ?
Pause. But you can show it to me later. Questions. As we look at these, question. Isn't this technically, as you go to infinity, infinity over infinity? L'Hopital's? Wouldn't this be infinity over infinity, L'Hopital's? Wouldn't this be infinity over infinity, L'Hopital's? Now pause. Check out this guy. Who's stronger? E to the x, swoop, or ln of x, swoop? E to the x is stronger. Eventually, this is going to end up being some sort of infinity plus or minus, I don't know, not 0. L'Hopital's. Take the derivative of the top and of the bottom. Who's going to break down first?
So big, super big, but ln of x is.
Who's going to break down first? ln of x. Who wins? Bottom. Bottom, this is going to end up being a 0. You could do L'Hopital's. You wouldn't want to do it 99 times, but you wouldn't need to, because one derivative of ln is 1 over. All of a sudden, everybody's in the bottom, nobody's in the top. How about number 3? Who's stronger?
Wait, no, bottom.
Bottom, because as you take derivatives, isn't this guy's degree going to tick down 1 by 1 by 1? Whose degree is never going to tick down?
Okay.
So I have 1 and 3. I have 1 and 3. Hold on. David, you said 21? Number 21, same exam. Sarah, these questions are recorded, kid. We did the A's, as many as we could on both. What is the value? 0 to 7. David, F is this guy. Integral is area. So I would have done a triangle, a rectangle, a triangle, a rectangle, a rectangle. Remember, all of these are going to be positive, and all of these, we'll just do that guy, are going to be negative. Find that, subtract that, done. And then Charlotte, you had a question on number 17, the same exam, 2013? Okay. Kiddos, quick heads up. Hopefully period 6's computer does not crash, although you guys might have gotten some questions answered. So you might see other things in there. But, oh, it's a derivative. Oh. Derivative of arc sine is 1 over the square root of
Oh, I don't remember.
1 minus
A squared.
u squared, which would be this guy, times u prime, which would just be 1. Why? Because my function f of x is equal to, we set that equal to 2 and solve. My function is equal to arc sine of x to a, and we're supposed to find f prime of a, which is why on all of your forever quizzes I have you write f prime of x equals the limit definition. Take the derivative of arc sine, plug in a, set equal to 2, dun 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 dun, bye. I will do more questions in period 6. You can check out their video tonight. Tomorrow, we're going over questions on sections B, both your mock exam, see what you have left when you try to correct, and the practice exam. Bye, guys.
So it's on the video?